Hello there, welcome to lesson 3 in our series on creating earrings using FluidDesigner for 3D printing. In today's lesson we're going to show you how you can create a wireframe Torus earring. So if you start FluidDesigner up, you need to go to Learning Projects, Jewellery Projects, Earrings first of all. And we're doing lesson 03, so it's 03 wireframe Torus earring. And I'll just start the screencast keys just in case there's any key presses I make. They'll be displayed in the corner of the window here. And this is the object that we're actually going to create in this lesson. Okay, so it's a wireframe earring, and clearly you would need some kind of wire fitment to go through there to attach it to your ear. So how are we going to create this object? Well, first of all, all the instructions are in the help panel over here, so let's just have a little look. Yeah, we're going to add a mesh and add a torus mesh. So add a mesh and add a simple torus. Now it's very important that this properties panel is open here. If it's closed, you can always click on the plus to open it, or you can press T on the keyboard, T to open the toolbox, open and close it. It just toggles it basically. So let's just zoom in on this object, and we'll go to view and zoom to select it to see what we've got. Well, it's just a simple torus shape at the moment. So it's just a ring made up of a number of major segments and minor segments. The major segments are the number of segments going around the object, so there are 48. The minor segments are the number of segments going around in this direction, and we'll see that as we change them. So at the moment this object is quite small, it's only 2.5 millimeters by 2.5 millimeters. So we want to change some of the parameters here. So we want to change the major segments down to 8. You probably can't see very much on the screen at the moment, but if I drag it right down to 3, yeah, what the major segments are the 3 sides at the moment. So this is a major segment, 1 major segment, 2 major segments, 3. So if we change it to 4, you can see you've got a 4-sided torus, 5-sided, 6, 7, 8, etc. So that's what the major segments are. Now the minor segments are the number of segments going around the object. So again, if I just take that right down to the bottom, okay, so 3 is the smallest number. This is now got a triangular cross section. There's a surface there, and a surface underneath. So there are 3 segments or 3 faces around the object. If I go to 4, there are now 4 surfaces around, 1, 2 and 2 underneath, and similarly 5 and 6. So we're going to do 6 minor segments for this lesson today. So our object is, so we've changed the segments, but we've still got X and Y dimensions, making it quite small. So the next thing we need to do is to change the major radius. So let's just see what happens when we change the major radius. Well, you can see quite clearly what's happened there. The diameter of the object has increased. So, oops, hang on a second. X is now 4.5 millimeters. Well, what that means is from let me just move it across a bit. From this side of the object to this side of the object, the external dimension is 4.5 millimeters, and similarly in the Y, 4.5 millimeters from the external to the external in the Y direction. What's that made up of? Well, the major radius is 2 millimeters. So in other words, it's 2 millimeters to the center of the tube there, 2 millimeters to the center of the tube there, so that's 4 millimeters from center to center, so that's the major radius. And the extra half, well, the extra half comes from the minor radius. The tube itself has got a minor radius, a radius of 0.25 millimeters, and if we add the 2 0.25s onto the 2 2s, we get an external diameter of 4.5 millimeters. So we want to change the major radius to 6. Okay, so that will essentially give us a size of about 12 millimeters across, so 12 millimeters from the middle of the torus to the middle of the torus here, so that's the 12, and then we've got a quarter of a millimeter and a quarter of a millimeter at each side, giving us a total of 12.5. Probably be a bit more clearer as we change the minor radius. All this does is thicken up the torus. Now we want a value of 2 millimeters. Now we need to be a little bit careful here. If we type in 2, it won't work. We go really thin, and you can see it says 0.01 millimeter. We need to do 2 mm. So if things go strange, just add the units, and there it is. We've got 2 millimeters now. So what have we got? We've got 16 millimeters for X and 16 for Y now. So that's made up of 6 millimeters from the center to the center of the tube, plus another 2 for the minor radius. So 6 and 2 gives 8 millimeters to the outside of the object from the center, 8 millimeters that side, 8 and 8 give you 16. And we can see that the height in the Z direction is 3.4 millimeters. Okay, so that's what we're going to do. So we've just added a simple torus, but in the properties panel here we've been able to modify it. So we're now going to change this again, and what we're going to do is we're going to create a wireframe effect, so that we can then put a little clip around the object itself and then attach it to your ear. So this is going to be an earring, yes. So what we need to do with the object highlighted, we need to go to the properties window. We need to select the modifiers icon, which is this little spanner, and we're going to add a modifier called a wireframe modifier, and it's quite clear what that's done. Okay, I'll just open up that panel there, and I'll just zoom in a little bit, so you can see it's taken away the faces of the object, and it's just left us with exactly what the modifier says. It's just left us with a wireframe. Now there are some values which we can change here, and settings that we can change. We're going to leave them as they are at the moment. It does tell you to do something different in the help window, but we'll leave them as they are at the moment. And we'll now add a solidify modifier. This object clearly not going to print. There's no real great thickness to this, and so we need to solidify it, and again that's a modifier. So we go to add modifier and we go to solidify modifier, and we are going to set a thickness value of 1 millimeter, and you can see that what that's done is each of the wires has now got a thickness to it, and we've now got this object. Now if we zoom in, what we should notice is that it looks a bit weird here, and what's happening is that as we create this object, because of the fact that we're adding thickness to wires, and those wires are pretty close to each other, and because we've got these offset parameters that we can change and set, it affects the appearance of this surface. So for example, the offset can be changed from -1 to +1, and it's the offset from the center line. In other words, if I just delete this solidify modifier at the moment, offset of 0 means that it adds material on one side and on the other side. If we set offset to -1, it only offsets it on one side of the object, and an offset of +1 only offsets it on the other side of the object. So an offset of 0 might sound like a sensible value, and it often is, but in this instance it's causing us some problems. It's causing some peculiarity in the appearance of the surface. So if I just put the solidify modifier back in again and set it to 1 millimeter, you'll see when I zoom in I've got this weird thing going on here. Now I have got an offset in the solidify modifier as well, and I can change that. I can change that to 0 and change it to +1. And really the only thing that you can do here is you've got to play around with these values and see which set of values give you the smoothest surface appearance without any peculiarities popping through. So if we change that back to -1 there, that's not having much of an effect because the wireframe itself is quite thin. Here, when we've solidified it, we've got 1 millimeter of thickness here. This is only 0.02. So this value is really the one that's causing the issues here of bits of the object pushing through. So you can play around with this, but the settings that we're going to leave it to in today's lesson are +1 and +1, and that gives us a relatively smooth surface appearance. Now there are other things that we could do here. We could tick relative thickness, and you can see that changes it slightly. Click boundary, doesn't seem to have any effect. Flip normals is not really, shouldn't make much difference here. We're going to try and fix that in Netfab Basic. If we click even thickness, things go weird look. So that's one we need to switch off. So you just need to play around with these values and try and get a smooth appearance. So we're now going to confirm these values, and we do that in FluidDesigner. We're going to Tools, Object Tools, and convert it to a mesh, so the modifiers disappear. What we now need to do is we need to delete the original objects at the bottom, and if we just save this one now that we've created in today's lesson. I'm just going to save it. So we go to File and always go to Save As, go up through the menu system, look for My Projects, Jewellery Projects, Earrings, and we save lesson 03 Wireframe Torus Earring, and we save that as a Blender file. Now we can't print Blender files, so we do need to export it in a printable format, which is we're going to use wavefront object format, and we like to save it to the desktop, so it's 03 Wireframe Torus Earring object file. And you then need to go to Netfab Basic and go to Project and Open, go to the desktop and open the Wireframe Torus Earring. Now we haven't got any warning red triangles there, which suggests that this mesh should be okay, but it's always a good idea to go to Extras and repair the part. And we just scroll the screen across, and you'll see there we haven't got any real problems. We've just got two shells. But if we run automatic repair anyway, it will triangulate the mesh. The mesh wasn't triangulated originally, so always do this. And click Apply Repair and remove the old part. And that now is in a printable file format. And what you need to do is upload it to Shapeways and then just double check that Shapeways or whatever other printer company you use will be able to print this based on the thickness of it. So we go to Part, export the part as a wavefront object, export it to the desktop, and it's a Wireframe Torus Earring repaired. That's the printable file. Thank you, and that's the end of this lesson.